Professor Dave here. Let's check the pressure.
He knows a lot about the science stuff. Professor Dave explains.
We used to think that air was just empty space, but in the modern age, we know that air contains matter. Specifically, molecules of nitrogen, oxygen, and many others. These molecules participate in collisions, where they transfer some of their kinetic energy onto whatever they collide with. This means that air exerts pressure on its surroundings, and we are able to measure this pressure. Atmospheric pressure decreases with altitude because fewer and fewer molecules have enough kinetic energy to go against gravity to get farther and farther away from the Earth, resulting in an atmosphere that thins as we go. For this reason, it will be useful to be able to quantify atmospheric pressure. One method of measuring atmospheric pressure is by using something called a barometer. A barometer is a glass tube that is closed at one end and then filled with a liquid, like mercury, that is chosen specifically because it is non-volatile, which means it does not evaporate but will remain a liquid. The tube is then inverted and placed into a container of that liquid. The atmosphere exerts pressure on the liquid when particles from the atmosphere collide with particles in the liquid. This activity keeps the liquid in the tube at a particular height. So by observing the height of the column of liquid in the tube, we can see how much the atmosphere is pushing down on the liquid. And in doing so, we are measuring atmospheric pressure. In terms of the liquid chosen, if we were to use water, normal atmospheric pressure can support a column of water over 10 meters tall, which is not terribly convenient for storing or taking measurements. For this reason, we decided to use a different liquid. Mercury is much more dense than water, so a mercury barometer will not have to be so tall. In fact, atmospheric pressure will support a column of mercury that is only 760 millimeters tall. And this relationship between the height of a column of mercury in a barometer and atmospheric pressure is where we get the conversion between atmospheres and millimeters of mercury as units of pressure. The pressure exerted by a fluid due to gravity is called hydrostatic pressure, which is represented by P, and is equal to the height of the fluid times the density of the fluid times g, the acceleration due to gravity. In order to support a column of fluid of a particular